Daily quiz is up.
Tuesday, November 2nd, a number of colleges will be here. Common Heritage College, which is here in Wyoming. College in the Commons in the morning, Dakota State University of Madison, 10:45, 11:15. Northern Aberdeen, South Dakota State University, looking to Augustana, which is Sioux Falls, to all be in the Commons over Tuesday, November 2nd. Admission counselors will be available for each of those schools to answer your questions about programs offered and admission.
Oh.
Have a great day.
So we're going to go to any pool parties this weekend?
No.
Any party, huh?
No.
I'm going to be an island. I don't go to parties. I'm the party super.
That's great. Do math. No. They're I live outside of town, and I generally don't trust anyone in South Dakota.
So do you just go buy them a big bag of candy and call it a day?
We carve pumpkins.
Oh, I love parties. Pumpkin party.
Wait, 4, 8, 10, 12, 14. 8, no. Huh. expected more of a reaction. All right.
Oh boy, a rat.
It's a rat. You know, just realize it's whatever kid sits in this spot, that it's usually just gobbling down food in every class.
Really?
Yeah.
Wow, this is the spot to be.
Have I put an S again? To inmode?
Second window.
Hey.
Mm-hmm.
What is that the independent?
Well, what are you trying to ask? Okay. No, you're not.
Oh, I'm sorry.
Copy down.
Yeah, it's looking good. Most of your... Looks like we got it. I'm seeing a lot of those little number lines. The same graph on people's screens. Looking like we're getting it. This good. Does anyone need more time? We're there? Okay. Hmm. Right out the gate. On my little number line, I know that I'm going to have asymptotes at -1 and 4. And Frank is cross-eyed. No, bad Frank. Not that. Thank you. Okay. I know I've got those already. I just got to find the X-Intercepts to go with it. To find the X-Intercepts, I'm going to need common denominators to solve. Like so. Because when I get a rational function, its features will tell me certain things like my denominator tells me vertical asymptotes, and my numerator is, what's that, 3x, right? Nah. 3x plus 2 minus 4 is minus 2. So numerator gets me x-intercepts because if I will just put this over 1 and cross multiply, I get 3x minus 2 equals 0. So solve for 0. Positive 2/3. Now, if I just know the behavior of the graph, I can use that to test things. Like, for example, this is 3x minus 2 over x squared minus 3x minus 4. If I plug a 0 in for x, I get a y-intercept at 1/2. So if I were to just kind of toss in a y-axis here, now I know that I'm going to have a y-intercept at 1/2. I have an x-intercept right there. Because the degree of the numerator is less than the degree of the denominator, I know that I have a horizontal asymptote right there. I get to just kind of sketch in what the graph's going to look like. So I can use the behavior to determine what's positive and what's negative. Or if that is not your jam, all I need to have is those and just test the intervals. It's going to be negative here, positive here, negative here, positive here. Okay. So whether you use the behavior of the graph or whether you just dump that in your calculator and then just ask feature, right? I'm curious, how many even use the behavior of the graph? Like, quick sketch of the graph to tell me what's positive and what's negative. Like 2, 3 of you? Maybe it just kind of confirms things. Who just says, screw it, and goes straight for calculator test mode? Who says, double screw it, calculator look at the screen?
Yeah.
I mean, how do I know how you tested those intervals? You've got the work to back it up to get the intervals. Fine by me. But I do need to answer the question, when is this thing greater than 0? It's going to be from -1 to 2/3, parenthesis or bracket, controversy, argue.
It's a bracket because it's
No, it's parentheses because it's just less than. No equal to there.
Okay. Now, if this was or equal to, you'd have parentheses on the asymptotes, you'd have brackets on the x-intercepts. That would be right. But in this case, because of that, I don't even have to worry about it. So parenthesis and then union from 4 to infinity and beyond. Dude, you guys see that they're making a Buzz Lightyear movie?
Are you serious, bro?
Like Lightyear the movie. And it's like Buzz's origin story. And they got Chris Evans to do the Buzz Lightyear voice. Captain America is Buzz Lightyear. Plus, like, Chris Evans is gorgeous, right? So, we got there. Captain America. Like, he's Captain America. Okay. All right. Did you get common denominators? Let's finish this first. Okay.
I think they're both are nice.
Depends whether you like fuzzy or baby smooth. Did you get asymptotes? Did you get X-intercept? Did you get the correct plus minus business? And then finally, was your answer correct in terms of parentheses and brackets? Okay. All right. Any questions? This stuff? Okay. All right. That can go away. Save that. Yo. That. Questions? Paul. I'm sorry I can't hear Paul because we're still geeking out about Chris Evans. Be quiet.
No, we moved on.
Oh.
We're talking about that in the
39. All right.
Oh yeah, 39 on 26.
39.
It was either
A playing field, community park, perimeter of this, area of at least this. Hey, as soon as I hear rectangle, perimeter, area, do you even remember what those are? Area is length times width. Perimeter is 2 length plus width, or 2 times length plus 2 times width. Okay. It gives me a perimeter. It gives me an area of at least, so that tells me I'm going to have my words. There's my inequality. Write an inequality that can be used to find the possible lengths. So blah, 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 blah. I need to have area in terms of length for my function. So I need to rewrite that perimeter equation so I can jam that into the area equation. Because right now I got too many variables. I've got area, length, width. 3 variables. I want 2. So perimeter 112. 112 is 2 length plus 2 width. Divide everything by 2, make your life easier. So 56 length plus width. So I will replace width with 56 minus the length. Because now my area equation is going to be purely in terms of length. Now I'd say area is length times 56 minus length. And then it tells me the area is at least 588. So I'm going to say the length times 56 minus the length is at least, so greater than or equal to, 588. Write an inequality that can be used. Ta-da. Solve the inequality. Well, now I'm going to want negative L squared plus 56. That's just a 5. $56L, subtract that 588 over. Okay. Now you can rearrange it in, any number of ways to write it. But is it factorable? Cool. I mean, factor, solve, do the thing that we were doing before, right? It's going to be a negative parabola. You're going to get an X-intercept and an X-intercept. Solve the inequality. Remember, those are the zeros. I want to know when it is greater than or equal to 0. So it's going to have a range of possible lengths because it's everything that makes the parabola greater than 0. So How does the inequality of a solution change if the area is no more than 588? So now it's going to take this thing and flop it. So now it's going to look like this instead. I take that back. It said no more than. So if it's no more than, here's my answer. Everything that's less than or equal to. Interpret the context in the situation, or the solution in context of the situation. Here's a range of lengths. The playing field can be from this length to this length. I don't remember. Yes. There's always a review like the quiz thing, so. Typically, the quizzes are supposed to be just, these are the skills that we've done. Do you know how to do these skills? So I usually try to avoid the word problem or application problems because that's an application of a concept, not the mechanics of the concept. Right? Like, no. Also, there's a bunch of inherent bias in word problems. Like, you take into effect your reading comprehension and fluency, vocabulary. Just being a special ed teacher, I also don't like having word problems on tests if I can avoid it, if it's not one of the standards that I'm assessing. So this is where we're headed. This is the point of math, is to be able to do it in context, but not necessarily what we need to assess. Besides 39 EU words. Nothing? Cool. All right.
Devices on the counters.
Scramble mode.
Can we wait till after the
Okay.
Moms can't live without their phones.
What? No.
For the scrambling.
Womp. 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 3. Womp. Womp. Womp and womp. Okay.
Anyway.
I don't remember who took what. After parent-teacher conferences, I had talked to a couple of students, a couple of parents. I always try to do the review and the quiz on one sheet because it, saved the planet. But the tree's already dead. Honor its sacrifice. Don't buy Bitcoin. There you go. So it is now printed as review and quiz separate sheets, which I know helps a lot of people in terms of transference. So that's why you only have the review in front of you. Womp. Write the linear factorization. You get your choice. I don't care how you find the factors. I'll tell you it is factorable. Your choice. Well, let's see what happens. If I try to aim for quadratic form, let's just see what happens if we go down that rabbit trail. Here I have t squared minus 10. Here I have t squared plus 6. I take out a 3, t, leaving a t squared plus 6. So it looks like it's easily factorable. They both have a t squared plus 6 in common, so t squared plus 6 comes out, leaving a t squared plus 3t minus 10, which is itself factorable. What? Oh. Okay. Change them to x's. So we have a, you know what? Since it is asking for linear factorization, y'all remember sum of squares? If that was t squared minus 6, it would be t plus square root of 6, t minus square root of 6. What's different because it's t squared plus 6? I's. So t minus I root of 6, t plus I root of 6, t plus 5, t minus 2. There you go, linear factorization. So it is factorable. Now, who's to say that you have to do it that way? You could have instead said 1, 3, negative 4, 18, negative 60. Sum of squares. I could try this instead. I could gaze into my crystal ball and I could feel awful lucky about negative 5. Getting negative 5, negative 2, 10, 6, 30. Really? Oh yeah, negative 30. There we go. So negative 12, so 60 gone. And say I feel real lucky about 2. And 2, and 0, and 0, and 6, and 12, and skadoosh. And then I recognize this as t squared plus 6. We'll set it equal to 0. T squared is negative 6, so t is plus or minus I root of 6. And then if you know all of your zeros, then you say t minus the 0. And that's your linear factorization. So 2 ways to do it, either factor it or synthetic divide, find all the zeros, solve the quadratic at the end, and then write the linear factorization. I will take both. I'll tell you the one on your quiz, factorable, without having to split a term. Okay? Womp, womp. Then there's an awful lot of rational function stuff because we spent a good amount of time on it because we hadn't seen it since Algebra 1, which for most of you would have been, what?
3 years ago.
Probably 8th grade, maybe freshman year. Either way, likely during the shutdown. So,
Oh my gosh, again.
And at least you know all at the front. I'm at the side.
Oh, like your hairline.
Your hairline at the top.
It's still
There we
there.
go, right in the middle.
what? What? What?
In the back of your head.
I'm going to math now. That's wrong.
I'm gonna say.
x minus 2, x minus 3. There we go. That's better. Now what? Okay. And then you graph what's left. So where are my vertical asymptotes? Positive 3. And I will label. And 0. Wherever you want to write it. What about horizontal? Or oblique? Like, what does it end up being? How do I know? Degree of the numerator is less than degree of denominator, so at y equals 0, I will have an asymptote. Do I have any x or y intercepts? Okay, x-intercept at negative 2, right? Yeah. So I'm going to cross through there. Typically, the behavior on those is if it crosses through, it will sneak through like that. So it'll like curl along the asymptote underneath it and then shoot through. That's just observation of behavior. We're probably going to want to just check our calculator and make sure. What about y-intercept? Because if I plug in 0 for all of my x's, I end up with negative 4 over 0. So no y-intercept. So now it's just a matter of jamming that into the calculator and finding what the rest of the graph looks like. So come over here. I'm going to plug in the original because then I'll still be able to use my ask feature to confirm the whole. Got alpha y equals, brings up the fraction, x squared minus 4, x to the third minus 5x squared plus 6x, graph of a, and it'll whoop. Okay. We've talked about this. You have to be smarter than the calculator. You have to recognize that that continues down forever, that this continues up forever. You have to be smarter than the calculator. What happened there is the graph itself is too close to an asymptote. And it's supposed to not show anything at the asymptote. It's only got so many pixels. It's going to just look like it cuts off. You have to be smarter than the calculator. Now, another way to confirm that is with that table ask feature. If I switch this over to ask, and if I think it actually stops at 0 like the graph showed, if I think it's just there and done, I should now be able to go to that table feature and say 0.00000009, and it's just going to tell me, no, there's nothing there. But it doesn't. It's heading down towards negative infinity. You got to be smarter than the calculator. You know that that curls along the asymptote. But I do now know what the rest of my graph looks like, so I'm going to plug that in. Curls along here and goes whoop, whoop, whoop. You should probably find some points on there. Getting there, Jesus. Okay. If I go back to my regular table, That was just confirming the whole this exists. Table. There we go.
If we didn't put any points on that, don't forget to label the hole.
We're getting there. Chill, chill, chill. I'm going to find some more points. Okay. Because I can't just leave the behavior like this. Well, go find some more. -3, -1/18. Well, that's pretty much what we figured. -1, 1/4. So still really, really close to the asymptotes. At 0, asymptote. At 1, it's -3/2. Okay, that helps. At 2, it's an error. Why is that an error if my asymptotes are... Okay, so that's another reason maybe we can switch over to my ask feature and get really close to 2. And say like 1.99. Okay, so it's going to almost hit 2, -2, but there's going to be a hole there. So at 2, -2, I'm going to put a hole. So it's going to, like, yeah. And then off to the other side at what? 4? 3/2. Okay, you don't have to overkill it. You don't have to put a bunch of points on there, but enough so that you have the general shape in terms of how close to the asymptotes you are. Labeling any asymptotes and intercepts. So I'm going to just, right next to this, I'm going to say -20. We got our asymptotes, we got our intercepts, we got the hole. Good to go. Who what? Oh. Sounded like there was argument, so.
Oh no, I was just wondering how you got the 2, -2. Like I get there's a hole there, but I didn't get how you got
You traced to either side of it. So like 1.99999, 2.0001. Basically the limit. The limit as you approach the hole is what it would have been if that was not a removable factor. I can plug 2 into what is remaining and get 2, -2. Okay. Again, if I want to find my X-intercepts correctly, do not label 1.73. Call it square root of 3. Okay? So, denominator gets me my vertical asymptotes, x equals -1. It does say to just label it, so if I write it there, that's okay. I still said what it is. It's still in the right spot. X-intercepts at plus or minus square root of 3. So 1.729 plus or minus. Here, negative square root of 3, 0. Square root of 3, 0. Okay, what else? My y-intercept, I plug in 0 for x. F of 0 gets me -3. Okay. We have our rules to determine horizontal or oblique asymptotes. It's always about the degree. Since the degree of the numerator is a 2, degree of the denominator is a 1, what? It's oblique. I need to divide to find what my oblique asymptote is. Because this is a linear factor, I'm okay with saying synthetic division. If it was a quadratic factor, like into a cubic, then I'd have to do long division. What do I do with that remainder? You ignore it. You're supposed to get a remainder. That's why this is an asymptote instead of a factor that is removed and get a whole. So I ignore this part and I just look at y is x minus 1 as a oblique asymptote. And with those handful of points, you can see where the graph's going to go, right? You can see where it's going to curl along the asymptotes on opposite sides. So, yeah, I'm just going to roll with it. If this is 1, 1 away, I'll do 1, 1 this way because that whole symmetry business. If this was up 2 over 2 plus square root of 3, I could go down 2 over 2 plus square root of 3. Like, you can get the symmetric values like that using those little L shapes like you're playing chess. Or you can just grab a calculator, right? Plot by table. It's how we have graphed things that we don't know how to graph since the dawn of time. Connect the dots. Bonus round! What are those called? That is not incorrect or official, but it's still an accurate descriptor. Good job. Something angles. What kind of angles? They are congruent because they are, starts with a V, vertical angles. Okay. Well, because I had a couple of kids come in asking about review for the PSAT yesterday. Like, do you even remember? Like, if you saw a question on an ACT, and it said something something vertical angles, would you know what the crap they're talking about? Okay. Yes, ma'am.
Is that the bottom left point that the very bottom one is off? And then what's your
2 plus square root of 3. Square root of 3 is 1.729.
wait, where's the two?
Because this comes up to and over. Oh, it is 1 square root. You're right. Yeah. I went 1 too far. Yes. The celebratory ha-ha does not help. All right. 4, same thing. Do it again. Again, x minus 3, x plus 2, x minus 3, x minus 1. What do I got? Womp, womp. There's my vertical asymptote with x equals 1. Here's my X-intercept at -2, 0. And if I plug in 0 for x, I get a Y-intercept of -2. No, -2. And then, because the degrees are the same, I'll look at my leading coefficients and say my horizontal asymptote is y equals 1. So then we jam all that stuff on here, have a y-intercept of -2, have x-intercept of -2, have a horizontal asymptote of y equals 1, have a vertical asymptote of x equals 1. And when you get that nice just single set of asymptotic axes, then it's symmetric about that point. If from this intersection I go left 1, down 3, then I can also go right 1, up 3. If from this intersection I go left 3, down 1, then I can also go right 3, up 1. I would say that's enough, right? I got my x and y intercepts. I've got 2 points on each side so I can see the curvature to it. I'd just go for it now. Where? Well, good thing I'm not over there yet. Okay. Because right there, I need to put the hole in. Now, the hole is going to happen at x is 3. The specific spot that it occurs is going to be at, what if I put 3 in there? If 3 was not a hole, the graph would exist at 3 5/2. So I kind of winged it. You don't have to actually say where it is, but the graph that we see is that stuff. Oh, you gave me like the rabbit from Pets.
No, yeah, I should have read the snowball.
Yeah. I love that GIF. Like the rabbit just staring at you, like twitching. Yeah. All right. Use the function in number 1 to determine what? So scroll on back up to 1. What were my real zeros? If my real zeros were at, weren't they like 5 and 2?
No, it's -5.
We just did it. Okay. So if I know that those are the real zeros, look at the end behavior of it based on the leading term. It's a positive t to the even. So that means it's going to start up at positive infinity, come down and do stuff, and head back up to positive infinity. And I know that my x-intercepts are going to be at -5 and 2. So if I have that information, considering that we already did the problem and found the zeros, it would be safer.
No, but like, zeros, then we use the calculator, plus or minus.
Yeah.
Yeah.
Signs are different. Just me.
What?
Like this. Did you go to the
So when is this function greater than 0? -infinity to -5, parenthesis or bracket, union 2 to infinity. When is it less than or equal to 0? Bracket -5 to 2 bracket. Okay. And then the last one is, just like our daily quiz,
Wait, so in the last one there was like 2 things? It's not
Because you subtract.
This guy needs x plus 1. This guy needs a x minus 4. And this guy needs an x minus what the? Yo, dude. Let's try that again. And this needs a x minus 4. Well, it's not just going to cancel because, like right now, they will all have that. There you go. Those are the words. Now if I take this whole honkin' thing times x plus 1, really?
Could you just subtract the 1 over x plus 1? Not 4?
I mean,
How would the denominator?
Yes. I'm going to have the exact same x-intercepts.
Oh, okay, so you just do.
No. Hang in there. Hang in there. Up top, 2x plus 2 plus x squared minus 4x. If I'm only looking for the x-intercepts, I'm now just going to say equals. Right? Because zero's of the numerator. It's a quadratic. Everyone over one side of the bus. X squared. Here's a negative 2x. Subtract negative 3x. Here's a 2 and 4 over. So plus 6. Ew. It's not factorable.
So either you get to do quadratic formula or complete square.
Seriously, what the? Like, it's a moving target. It's getting aligned in one corner and going 3 inches off in the other. Half of negative 3 is negative 3 halves. Negative 3 halves squared is? X plus b over 2 squared is now negative 24 fourths plus 9 fourths is negative 15 fourths. What's going to happen when I try to solve this? So what are the x-intercepts? There are none. So the only things that I need to test on my number line are negative 1 and 4. Because there aren't any x-intercepts. Because there is no place that it's going to switch between. Now, when you see all this, because when I try to solve now, I'm going to do the square root of a negative imaginary number. No, you always use the original because just like when we plug in a function that had a removable factor. Okay, now here's what Claire's asking. We get everything over to one side. This is why I said it doesn't matter. If I were to subtract this over, I now have minus that, right? But doesn't that just mean that? Which still equals this. Like,
Which one's faster?
they're the same thing.
Yeah, you're just.
They're the same amount of steps. They're just a different order.
Yeah, you just
Instead of moving it over here, I moved it here. Same thing. Okay. But either way, I end up with there are no X-intercepts. But you do make a note to yourself. Tell yourself this. You have to find the asymptotes and the X-intercepts. It might not have one or the other. Maybe you get a function that only has a horizontal asymptote and the entire thing is above it. I don't know. Maybe you get something like this that never hits the x-axis. It's possible, but you have to try to find the vertical asymptotes and the x-intercepts. Then, testy. Jam a -2, a 0, and a 5 in there. What does it look like? No, you tell me. I heard a positive, negative, positive. Is that true?
That's X.
-1 over x plus 1.
Yeah.
Well, now I'm like irritable.
I don't know
So,
how you guys can even see that.
well, there we go. Plus, minus, plus. Or go to your table, switch it over to ask. Right there? I got negative. Okay. I got negative. I got a positive on the outside. Positive on that side. Yeah? Okay. Make a note to yourself. X-intercepts and asymptotes. How you test it is up to you. You can find the behavior of it in Sketch. You can use the ask feature. You can gaze into your crystal ball. But you got to have that little number line to show what you're testing and where. Okay? Oh, I never actually wrote the answer. It was when is that greater than 0? So it was negative infinity to what was the first asymptote? Union. What do you mean? Okay. Where this is greater than this is going to be the same as where this is greater than 0. The same area. All I did was do a vertical translation of it. So, now you may scramble up and dump your phones over there. And your smartwatches, and your spy cameras, and your Google Glass. Okay. All right. Oh yeah, I'll end the stream right now. Scramble yourselves up. Okay.